Okay, so we've spent time looking at exponential equations. We're now going to take a look at some logarithmic equations. So these are equations, right? Has an equal sign involving logarithms on either side of the equation. So here's the general guidelines. Just like we isolated the exponential expressions, here we isolate the logarithmic term on one side of the equation. And in order to do this, we may need to apply laws of logarithms that we learned about previously to combine the logarithm as a single quantity, or condense the logarithm as we were doing. We'll see some of that. After we do that, we're going to write basically the logarithmic equation in exponential form, or raise the base to each side of the equation. I call this exponentiating. I don't know if that's a real word, but that's what I use. Then we'll solve for the variable. And then again, what do we want? Both exact and an approximation. Now, of course, if the exact solution is like x equal 3, you don't need to approximate that. Okay? So sometimes these we won't need to really approximate or approximate them, because the exact one will be just a rational number, or or even an integer. And then we will check, though. Make sure we check. That's going to be important. Okay. So let's see this. Log base 3 of 2 minus x equals 3. All right. We have a logarithmic expression over here. All right. Equals, right, 3. And the variable is inside the logarithm. That's important. So this is a logarithmic equation. We want to isolate the logarithmic expression. It is isolated. And that's the first step. Number 2, we're going to write it in exponential form. So how do we do this? How do we write in exponential form? Well, log base 3 of 2 minus x is 3. So the base is what? 3. The logarithm is what? The exponent. What is the logarithm? It's 3. 3 to the third power equals what? 2 minus x. Okay? Or you can exponentiate, and by that I mean take 3, which is the base, and raise it to this power, log base 3 of 2 minus x, and that must be equal what? 3 raised to the third power. But what is 3 raised to log base 3 of 2 minus x? That's just 2 minus x. Right? So exponentiating is what I call this. But it's just rewriting it in logarithmic form, because you'll see this equation and this one are the same. Right? So in either case, right, if I do it either way, what do I get? I get 2 minus x equals what? What is 3 cubed? 3 cubed is 27. 3 times 3 times 3. And so if I subtract 2 from both sides, I get negative x is 27 minus 2, 25. And so x is negative 25. That's exact. I don't need an approximation, right? There's no logarithms or e to the some power or something like that. That's the answer. Now, can we check this, right? Can I check that this is indeed a solution? Yeah. Go back to the original, right? Log base 3 of 2 minus x, which is what? Negative 25. Does this equal 3? Well, what is 2 minus a negative 25? That's 2 plus 25 is 27. Is the log base 3 of 27 equal to 3? What is log base 3 of 27? The power of 3 needed to get 27. 3 to what power is 27? 3. It checks. So it satisfies that logarithmic equation. Okay? Let's try one more. Where's our logarithmic expression in this one? Can you find it? It's right here. Okay? Now, it's got a plus 2 and it's got a coefficient of 6. I want to get rid of those. How do I do that? Well, the first thing is subtract 2 from both sides. (14 minus 2 is 12). And then what? To get rid of the 6, since it's multiplying, I'm going to divide. So make sure you do the right inverse operation. 6 divided by 6 is 1. 12 divided by 6 is 2. Now, can I divide both sides by 3 because this is 3x? No. This 3x is inside the natural log function. This is not multiplication. This is not ln times 3x. Can't divide by ln. That makes no sense whatsoever. Right? So you can't do that. But what can you do? You can write this now in exponential form. This is logarithmic equation. Natural log is what? Log base e of 3x is 2. The logarithm is 2. The base is e. E to what power? 2 is what? Is 3x. There's the exponential form. So if you remember, when we first started logarithms, we talked about writing the logarithmic form into exponential form. Very important. You have to practice that. And there was lots of practice in the homework. I hope you've done that. You've got to be able to go between these two expressions very easily and rapidly. Well, what's x then? Just divide by 3, or multiply by 1/3, e squared divided by 3, right? That is the exact solution. What is this approximately now? So now we want to approximate, and we can use the calculator to do that. I would just do e squared divided by 3. And we'll do 5 decimal points again, 2.46302, right? Since I've got an 8 there after the 1, I round that 1 up to a 2. So there's the approximation. Okay. Check and see, does this work? I'm going to use that approximate and plug it back into here. So I've got 6 times, now I do have a natural log button, so I can use that now. 3 times answer, close parentheses, right? Plus 2, that should equal what? 14. And it does. So it checks. Okay, so there's the basic idea. In the next video, we will do some more complicated looking examples.